Good day everyone. In the last video, we saw one case study sum in application of derivatives. Today we will see another sum in the same chapter. Now this sum I have taken from NCERT Exemplar. I have reframed the sum as it is a case study sum. A metal box with a square base and vertical sides can contain 1024 centimeter cube. What does it mean? The volume of the box is 1024 centimeter cube. That you must understand. The cost of the material for top and bottom is rupees 5 per centimeter square, and for the sides is rupees 2.50 per centimeter square. That is, if you want to construct a box, the metal part will be in the base, on the top and on the four sides, right? So now the top and bottom, that is the square parts, no, you have to pay rupees 5 per centimeter square. For the sides, it is 2.50. This is the information given. Based on the information, answer the following. And a figure is given here. Now this is the metal box with a square base. The side of the square base is x, that is given, and the height is h. Okay, this is the information. Now the first subdivision is relation between the variables x and h is. Now where will that x and h will be connected? For that, there is only one information available, that is the volume is 1024 centimeter cube. So you know V is equal to 1024. For any cuboid, you know the volume formula is length into breadth into height, correct? But now, because it is a square base, you will be getting the volume as x into h, that is equal to 1024. So x squared h, that is 1024. So this is the relation between x and h. So here, let us check the options here. The option B, okay, that is your correct thing, that is x squared h, that is equal to 1024. So the first is very simple. Hope you understand this. Now the second subdivision. Area of the metal sheet required in terms of x is. Now first of all, let me explain to you what is the area of this metal box. That is the area of the metal sheet required, isn't it? So now you just imagine this is our metal box, right? So here the top and the bottom, let us say they are square, and on the four sides you have four rectangles, right? Now the area of the metal sheet required will be, the top you will be requiring one, the bottom you will be requiring one metal sheet, on the four sides you will be requiring four metal sheets. Now the top is a square, the side of the square is what? X. So x into x, that is x squared. Similarly for the bottom you will get x into x, x squared. So now for the top and the bottom, the area you will be getting will be, A will be 2x squared, okay, x squared plus x squared. Coming to the sides, here this is x, this is h, so this will be x h. Like that, how many rectangles you have? You have four rectangles, so that will be plus 4xh. Hope you understand it clearly. One square, two squares, x into x, x squared plus x squared, 2x squared. You have four rectangles. For one rectangle it is x into h, xh. For four rectangles, that is 4xh. So this is the area, but we want only in terms of x. So now in the previous subdivision you derived V is equal to 1024, it is given, that is x squared h is equal to 1024. So from this I can say h is 1024 divided by x squared, okay. So use that now. So now A is equal to 2x squared plus 4x into, for that h you write 1024 by x squared. One x will get cut, so you will get 2x squared. 4 into 1024, that will be 4096 by x. So this will be the area of the metal sheet required in terms of x. Check your subdivisions where it suits. That is subdivision D. So the area of the metal sheet required is 2x squared plus 4096 divided by x. Is this clear to you? So you should understand whether it is a open box or a closed box. In some sums, no, they will give open tank. So there won't be the top square. There only the bottom square will be there. Then you will only get x squared plus 4x. So be careful to read the sum. Each and every word in the sum is very important. Here nothing is given like that. So it is a closed one. So I have taken a square on the top and a square at the bottom. Okay. So these two subdivisions, I hope it's very clear to you. The third subdivision, cost of the material in terms of x is asked. Now, in the cost, you should note there are two differences, no? That is, the cost of the top and bottom is rupees 5 per centimeter squared, and the cost of the material for the sides is only 2 rupees 50 paise per centimeter squared. Now, already you know the area. That is, in the area, this 2x squared refers to the area of the top square and bottom square, which is 2x squared. This 4096 by x is actually that 4x h, in which in the place of h we have substituted in terms of x. So this is the area of the side and this is the area of the top and bottom. So now we have 5 rupees for the top and bottom, right? So it is 5 into 2x squared plus, for the sides it is 5 by 2 into 4096 by x. Okay, so now let us write this as 10x squared, and this I can cut. I will get 48. I will take another 2 so that I can take one 10 common. So this is, I can write 10 into 1024 by x, right? That is, this 5 is there. That 2048 I am writing 2 into 1024. That 2 I am multiplying. So 110 I can take out. I will get x squared plus 1024 by x. And this is the cost actually. This is A and this is the cost C. Because 5 into this plus 5 by 2 into this. So now let us check the subdivisions. See, everything looks like somewhat similar. Be very careful. So we will get only the C. So the option C is correct. 10 into x squared plus 1024 by x. So you have to be careful in calculating the cost. It is not the same because it is different. For the top and bottom, one cost. For the sides, it is another. So properly multiply and then get the expression. Okay, is this clear to you? Now the fourth subdivision. Find the value of x if the cost C is minimum. You know, for anything to be maximum or minimum, the first derivative will be equal to 0. A very important concept you have to remember. Now you know the cost, that is C. You have already arrived 10 into x squared plus 1024 by x. Now let me write it properly. This is 10 into, I can write x squared plus 1024 x power minus 1. If I write like this, I can differentiate it easily. So now I have to find dc by dx. I already told you, don't always think it is dy by dx. Whatever letter is on the left hand side, put it in the numerator. Whatever variable, what letter here, that you have to put it in the denominator. So dc by dx is, write the 10 as it is. For x squared, you will be getting 2x. Then plus 1024 into x power minus 1 is minus 1, x power minus 2. When you differentiate x power minus 1, you will be getting minus 1 x power minus 2. So let us write it properly. 10 into 2x minus, you will get 1024 by x squared equated to 0, because the first derivative is 0. The 10 cannot be 0. So here you can take an LCM. So you will get 2x cube minus 1024 is equal to 0. So you will be getting x cube is equal to 512, which gives you x is equal to 8. So now look at the subdivisions. The option B, that is x is equal to 8, is the correct answer here. So here, if you know the cost, first find the first derivative, that is dc by dx, equated to 0, and then you will be getting the value of x, and that subdivision you have to mark it here. Hope this is clear to you. The fifth subdivision, find the least cost of the box. Now you have already found x is equal to 8. You know the cost function, that is c is equal to 10 into x squared plus 1024 divided by x. So just substitute x is equal to 8. So what is c now? 10 into 8 squared, that is 64, plus 1024 divided by 8, right? So you will get 10 into, this is 64. If you divide this, you will be getting 128. So it is 10 into 192, which gives you 1920. Because this is the cost, this should be in rupees. Now you check the subdivision. You have actually two answers in 1920. But here see, they have given centimeter. Can the cost be in centimeter? No. So the subdivision A is correct, like this, no? Sometimes you must be careful about the units. They may give for volume centimeter squared, centimeter, like that they may cheat you. Or centimeter, meter, like that they can give you. So be very careful. So here the subdivision A is the answer. So hope you understood all the 5 subdivisions. So here for each figure, you should be very clear about all the mensuration formulae. That is very important in any maxima minima sum. Then you understand what is given, and then you go subdivision by subdivision. They will actually lead you, no? You will be using the result in one subdivision to the further subdivisions. Okay? So, thanks for watching the video. You subscribe to the channel, and then you can click the bell icon to get notifications of further videos. Thank you again.